go live. If someone could, I think there's one person on the YouTube link, so if I don't know if it's someone who is in this meeting, but if someone could just let me know if there's any audio issues or anything on YouTube, that would be great. Or if things sound good, then I'll get started in just a minute. Okay. That should be the case, yeah. Okay. Can you... That's fine. All right, so it is 10:01 and I'm live on YouTube now, so I'm going to go ahead and get started. Hi everyone, I'm JJ. I'm a developer relations engineer with Deephaven Data Labs, and I'm here today to talk about some best practices and standard use cases for getting data from REST APIs from Python. So without further ado, let's just go ahead and get started. So first and foremost, what is a REST API? Well, a REST API doesn't have a strict definition because a REST API is simply a web-facing API that adheres to the REST architectural style. The REST architectural style, I won't get into a definition here, or I won't talk about it extensively because that would be a learn session in and of itself. But the REST architectural style is one that is designed to be lightweight and scalable for web-facing applications. So, as I'm sure most people know, millions upon millions of people use the web every day, so it's completely reasonable that if you're going to make a public-facing API that you may get thousands to even millions of requests in short time spans. So the REST architectural style is simply an architectural style that's meant to be lightweight and with lightweight connections between the client and the server such that it can handle large amounts of requests and process large amounts of data at once. So standard REST API usage looks like the diagram I have here on this slide. So the client, perhaps someone like me from on my laptop here, would make a request to the API itself. The API will convert that into an HTTP request. The server will process the request, make a response, and then the REST API will give me something back. And if I made a valid request, the response can be in a few different formats, the most common of which is JSON, and that is the format that I'll be dealing with today when I do some examples. That's the basics of it. Again, I'm not going to go into great detail because there's a lot of considerations to be made when creating, designing, and maintaining a REST API for your own use. So why would you use a REST API? Well, first and foremost, as I just mentioned, they are flexible. They can contain a large amount of different types of data. Not only that, but they are also scalable. So because REST APIs are web-facing, and as I mentioned, millions of people use the web every day, your REST API should be designed such that it can handle large amounts of requests at once. So REST APIs aim to make the connection or aim to make the relationship between the client and the server as lightweight as possible, which means that the API itself can handle more requests than if you use something like a SOAP architecture, which is an actual set of design constraints that is much more limiting and heavy than a REST API. It is also scalable, so it's meant for web-facing interfaces, so it's meant to be accessed by large numbers of people at once or large numbers of clients at once. And then one of the coolest things is that REST APIs can actually handle hypermedia. I won't deal with REST APIs that contain hypermedia today, but hypermedia includes images and audio and video and things like that. Today, I'll just be dealing with text-based data. It may be worth it to have a talk in the future on accessing hypermedia from a REST API, but I'll save that for a different day. So what are REST APIs used for? The examples that I'll use today pull historical data from a REST API. I'll be pulling historical cryptocurrency data from CryptoWatch's freely available public data API. They can also be used for real-time data, although it is not the absolute best way to acquire real-time data, since it's not really a subscription service. You'll be getting snapshots of data. However, I have worked with REST APIs that update in real time for near real-time applications, because maybe I pull data once every minute, and so the data is real time as soon as I pull it, but then it takes some time to process, and it ends up as a near real-time application. And then lastly is cloud applications and services. These can range from apps on your phone to websites to other subscription-based services. But for instance, maybe if you have a banking app on your phone and you use it to access information about your bank account, it's actually entirely possible that the software itself is pulling data about your bank account from an internal REST API. So applications like that are fairly common for REST APIs. So there are 4 types of requests that you can make to a REST API. They are, as you see on the right-hand side of the screen. The GET request is a request to get data, as the name suggests, from a REST API. A PUT request is a request to update a field in the API. A POST request is a request to create a new field in the API, and a delete request is, as the name suggests, a request to delete or remove a field from the API. And today for this talk, I will concern myself only with GET requests. If I wanted, the other 3 requests deal more with maintaining or creating or updating the API itself. However, for today's talk, I'm concerned only with acquiring data from an API, not actually modifying it. So I'll be dealing today with making GET requests to REST APIs from Python. So making a GET request to a REST API can be done in 3 steps. The first is to simply make the request. The code block on the right, you'll see I use the requests package. There are a few different packages from which you can make a GET request to an API. However, the requests module in Python is designed to make web requests, so it is very, very useful and powerful for requesting data from REST APIs. So from when I do examples after the slideshow is finished, which will be shortly, everything I'll be doing will be using this requests package. So to make the request using the request package, you can simply use requests.get, which makes a GET request to a particular URL. And you'll get a response which has a few different attributes, which I'll cover in a little bit. The second thing you'll do is you'll check the response of the request itself. When you use the request package, the response has an attribute called status code, and that status code is an integer number, which corresponds to whether or not your request was successful or it failed. And it can fail for a few different reasons, and usually those reasons have different status codes. But if your request was successful, the typical status code that you'll get back is 200. So if you print the request status code and you see a 200, that means your request was successful and you got some data from the REST API. It may not be exactly the data you were looking for, but if you gave it the right URL, then you got the data that you were looking for and the request was successful. And then lastly, which is the most challenging, but also the most fun part of it, is to parse the data into whatever format that you want for your application. So the response object, or the response that you get from a GET request from a URL with a request package, has a method called JSON. I'll be using that today to parse data, and I'll show a little bit about what that looks like in a Python session. But this JSON method returns a JSON object in Python, which can either be a dictionary or a list of dictionaries or something like that. And before I jump into examples, the examples today I'll be performing will not be using an API key. However, many REST APIs out there require the use of an API key, or they may have a free way to use it without an API key. However, those free uses have constraints, and in order to use the REST API more, you are required to get an API key. So in order to do so, if you go to the website for the REST API that you want to use, there's almost always a link to obtain an API key. Sometimes you have to provide payment method, which I have done in a couple of instances, and for the most part, adding payment method won't require you, it won't charge you anything until you start using premium tier usage plans, maybe more than a certain amount of requests in an hour or a month or something like that. You'll want to add the API key as a variable to your Python session. The typical best security practice is to do so using environment variables. The Python's OS package has utilities for getting environment variables as a variable inside of Python. And then lastly, you'll just want to add the API key to the URL in your requests. Standard addition of an API key to a request is done at the end of the URL. So let's say you have a URL, you'll usually add something like a question mark key equals or ampersand key equals or something like that. And it's gonna change a little bit depending on which REST API you're using, but the website's documentation should have exactly how to do it. And then the last thing for using an API key is that you should never share your API key, even if there isn't a payment method associated with it, because REST APIs want to know that it is the person who obtained the API key who is making the requests. Also, if you've paid for the API key or you've got a premium tier usage you're paying for and someone else gets your API key, you're officially going to be paying for their premium tier request, which you obviously don't want. So that's what I have for a slideshow. I just want to show some simple examples pulling from a REST API. So I'm going to head over. First and foremost, I'm also on a Google Meet here, so I just need to share a different tab. Give me 1 second. I will be using examples from the CryptoWatch REST API. So here I have CryptoWatch's website. They offer more than just a freely available REST API. They have a whole bunch of cryptocurrency stuff that you can use. But if you scroll all the way down to the bottom of their main page, you can see here in the docs section, public data API. If you click on that, it will bring you to their documentation. And before I jump into examples, I want to just briefly discuss REST API documentation and typically what it looks like. So this is the landing page for the CryptoWatch REST API documentation. Most of what I've seen is there will be a menu on the left-hand side with the available interfaces as well as some information. Typically, if there is a drop-down menu, that's an available interface that you can pull from. So CryptoWatch's freely available REST API or public data REST API has 4 different interfaces you can pull from. As you can see, these 4 have drop-down menus, and then there's 3 pages on using it. So this is pretty good documentation. This is also a fairly simple REST API. So sometimes, in some cases, I've seen ones with dozens and dozens of interfaces to pull data from, and the API can get a little more verbose and complex. But typically, this is the format that you'll see. So this has information for getting started. They have here an example using curl. So this would be using a shell script or from a terminal. They'll curl a particular URL. In this case, they're pulling, they want to pull data from the Kraken exchange for Bitcoin in euros, and they want to get the price, and it'll get you a current price of Bitcoin and euros on the Kraken exchange. And I won't be pulling from this particular exchange for my examples today, but this is what the standard use case would look like. So in my examples, I'll do 3 of them today, the first of which I'll pull from the exchanges interface, and what I'll do is I'll get a list of available exchanges and some information about them. After that, I will pull from the assets interface, and I will get details on one particular asset. I'll get details on Bitcoin, and the details will be which exchanges they're available for, what currencies they're available for, and then last but not least, I will get information on markets. And on CryptoWatch, a market is a coin and a currency listed on an exchange. So what I'll do is I'll get OHLC, or Open High Low Close, historical crypto data from the CryptoWatch REST API for a given pair on a given exchange. And so without further ado, let's just hop on over to my Deephaven session, share one different tab, and share one different tab. And here is my Deephaven window. So I have 3 scripts here at the bottom of the screen. I'll be doing these in the order that that they appear from left to right. And I'll be making 3 different REST API GET requests from these scripts. So the first of which, as I mentioned before, I want to pull from the exchanges interface on the CryptoWatch REST API. And so it had the URL in the documentation as https api.cryptowatch/exchanges. And so I set the URL. As I pointed out in the slideshow, you'll make the GET request by just calling requests.get. I don't have the import statement here for requests. I imported it earlier, so let's just pretend I did that. So I'll make the GET request, so request.get URL. I'll get this response object, which has a few different attributes. I actually don't have it in the script, but I just want to show what's available. So if we look at this, we see different fields in this response variable. You know, you've got content consumed, next, blah, blah, blah. I'm going to be looking specifically at status code right now. So the status code tells you what if your request was successful or not. So in this case, I got a status code of 200. A status code of 200 from every API I've used is a successful request. So I successfully got a list of exchanges and their attributes from the REST API. The next thing I'll do is I'll convert this response, the data from the response, into a digestible format for Python. And so the response object has a method called JSON, which will get me the data. And so first off, I just want to show what kind of data I'm working with, and I'll be working with a dictionary is what you get out of it. Typically, when you call this JSON method, you'll end up with either a dictionary, which is just a set of key value pairs. Sometimes it's nested, sometimes it's not. Or you'll get a list of dictionaries. And these key value pairs are obviously in JSON format, and so you can access different attributes of the object itself by just passing in a key, and so on and so forth. So if I print this data out, you'll see a bunch of stuff here. It's just a big wall of text, but if we take a look at the top, of it up here, we can see it has this result field. And then this result field is a list of dictionaries. So if I'll highlight this first one here, and we can see that this first one has an ID. So it's got an ID of 1. The symbol is Bitfinex. So that's the exchange that's the first exchange they have listed. It has a name and it has a root. And it also has whether or not it's active. So it is an active cryptocurrency exchange. So that's cool. Another thing that I want to point out about CryptoWatch specifically that I haven't seen elsewhere that's really cool is that every response you get from CryptoWatch has an allowance field when you convert it to JSON, and this allowance field tells you the cost of the request you made as well as how many CryptoWatch credits you have remaining. So with CryptoWatch, you start out with 10 credits a day, and then each request costs a certain amount of credits. The request I just made cost 0.002 of a credit, so I could make 5,000 of these requests. I don't think my math is right there. You can make thousands and thousands of these requests every single day, and that would be completely free usage. These requests on CryptoWatch cost anywhere from 2,000 to 0.015 to 15 thousandths of a credit. So anyway, I just pulled data from the exchanges interface, and I got some data, and I didn't really parse it, but I showed what it looks like. So you could parse it by cycling through each field of the dictionary. I next want to come to my next example, and I'm just going to clear the window here. So the next example, I want to pull from the assets exchange, and an asset on CryptoWatch is simply a cryptocurrency. So I'm going to pull data for Bitcoin. So they pull by symbol, so Bitcoin's symbol is BTC. I'm going to use a Python F string here to set the coin. If I highlight this, you can see that I put my variable inside of curly braces in this string, and I placed an F at the left-hand side. And so an F string allows you to place variables inside of a string, regardless of their type, using curly braces. I highly recommend, if you're going to be pulling from REST APIs in a programmatic fashion, that you use F strings to do so. I'm going to do all the same stuff. I'm going to make a GET request to the URL using request.get. I'm going to print out the status code. I got a 200. That's good. I'm going to get the JSON data using the JSON method. I want to print the type of data first. We end up with a dictionary again, and then if I print the JSON data itself, we'll see it's a giant wall of text once again. And so I have a bunch of stuff. And if we look at one field in this dictionary, we can see here, for instance, that this particular asset, or rather, this is what they call a market. A market is a coin and a currency on an exchange. So, for instance, this is on the HIT BTC exchange, and the pair or the coin and the currency is Bitcoin and whatever the YCC currency is. And we can see that it's active, and it gives us a root. So this gives us a whole bunch of information on markets that we can pull data from with CryptoWatch. And so the last script I want to run is this one. I will pull OHLC, or Open High Low Close data, for a particular market from CryptoWatch. So as I mentioned before, a market is a coin and a currency listed on an exchange. So I'm going to go ahead and set, and just actually clear these again to get rid of all that stuff. I'll set my three variables here, my exchange, my coin, and my currency. I'll once again use an F string. We can see I set the exchange and the coin and the currency here. It might be hard to read because the string is, it's kind of grayed out. But anyway, I'll run it, and I'll just print the URL to see that the URL is api.cryptowatch markets. I'll be pulling on the Bitfinex exchange for Bitcoin in US dollars. And then /OHLC tells CryptoWatch that I want OHLC data. I'll make the GET request. I'll once again print the status code. I will get the JSON. And then lastly, I'm not going to print the whole thing because it turns out that this particular request, this is one of them that costs 15 thousandths of a CryptoWatch credit. It turns out that you get an insane amount of data from this. You get historical crypto data for Bitcoin in US dollars on Bitfinex for 14 different granularities ranging from a minute to a week. And Bitcoin, they have data dating back to 2013, so obviously it's a ton of stuff. But I will access the result field, and then this 86,400, the fields are marked by the number of seconds per in between each data point. So 86,400, there are 86,400 seconds in a day, so it's one data point per day. I will separate it out via that. So I have this variable daily prices. I'll just print the length, and we'll see that there are 3,165 days worth of prices there. And if I print the first in this object, we'll see a bunch of information. This happens to be a timestamp in seconds, or seconds since the epoch 0. We have open, high, low, close, volume, and quote volume. And so as one last thing, I just want to print list there's JSON data result. And so that didn't work. Anyway, what you'll end up with is, as I mentioned, you get 14 different granularities, or 14 different frequencies at which it pulls data from, ranging from a minute. So this key would be 60 here, all the way to a week, which is something like, I don't know, 600 some odd thousand seconds in a week. So with that said, that's it, all I have for presentation. I was hoping to stay around 20 minutes, and that's where I'm at. So I just want to end it there. If anybody has any questions, please ask in the YouTube comments. I'm also on a Google call here, so sometimes people ask questions and cannot. And my desktop audio is not, you can't hear it from YouTube. So if I get questions on the Google call, I will repeat them before answering them. Anyway, I'll go ahead and ask now if you have any. Sure, that's a great question, and I would have liked to touch upon that, but I'm trying to keep it to like 20 minutes or so. So for anyone on YouTube who didn't hear that, the question was, what's the best way to ingest this data in a way that's good for Deephaven, or for like a streaming service? So Deephaven has its tables which allow for streaming data. So I have there's a repository for which I'll include the link in the GitHub description, in the video description below. But I have a publicly available GitHub repository you can use yourself, which will pull data from CryptoWatch into Deephaven tables. And so when you're pulling into Deephaven, if you want the data in a format digestible for Deephaven, specifically Deephaven Community Core, there are two best ways to do it. The first is you can use a pandas data frame as an intermediary. If you have a list of dictionaries in as a variable in Python, you can create a pandas data frame directly from it. So something like, if I import pandas, I can say pd df equals pd dot data frame list of dicts. And so If all of these dicts have the same, or these dictionaries have the same set of keys, what you'll get is simply a pandas data frame that looks like that. Deephaven has a pandas submodule where you can convert a data frame directly to a table. So that's one way to do it. And the second would be using dynamic table writer, and you can cycle through every field in one of these things. Say, for instance, my daily prices, I can cycle through every single price in my, or every single day in my daily prices, and then set, here's my timestamp, here's my open, high, low, and close, and then use the dynamic table write to write on a per row basis the data to a table. All right, and if there are no other questions, I will end it here. So thank you to all in both YouTube and the Google call that I'm in to coming to the talk today. Appreciate your participation. Whether you're here live or after the fact on YouTube, please ask questions in the comments section if you have them. We will answer them as soon as we can. So thank you. Happy Friday, and have a great rest of your day and a great weekend.